All right, welcome to partitioning a line segment. In this video, we are going to be, surprise, surprise, partitioning a line segment. We have this line segment here. We're going to partition it, meaning we're going to break it into parts, into smaller pieces, so that those two pieces have a ratio, their lengths have a ratio of 2 to 3. And we're going to do that by placing some point Q here, so that the distance from A to Q, the ratio of that distance to the distance from Q to B is 2 to 3. So AQ will be 2 parts, to QB's 3 parts. So QB is going to be a little bit longer. So altogether, here's the first thing we're going to look at. Of course, the first thing we look at is, which part is which. Notice AQ to QB. Make sure we get the ratio correct. Which side is going to be the larger side, which side is going to be the smaller side. AQ is the 2, QB is the 3. So we know that Q is going to be a little bit closer to A than it is to B. Next, we need to figure out how many total parts to divide this line segment into. Well, if we want a ratio of 2 to 3, we're going to need a total of 5 parts, so that 2 of them can go to AQ and 3 of them can go to QB. To partition the segment into 5 parts, we're going to see how far is it over, how far is it up. What's the horizontal and vertical distance between the points? So from B over to A horizontally, and we can call this, by the way, delta X equals 1, 2, 3, 4, 5 spaces. And our vertical distance, 1, 2, 3, 4, 5, 6, 7, or delta Y, equals 7. So over 5, up 7. And to divide the line segment into 5 separate pieces, we just need to divide each of these into 5. So we're going to go 5 divided by 5, which happens to equal 1, and 7 divided by 5, which happens to equal 2 divided by 5 is 0.4, so 1.4. All right, so we divided the horizontal distance by 5 and got 1 space. So each of our parts is going to be over 1, and our vertical distance is 7, which we divided by 5 into 5 separate parts, and we got 1.4. So horizontal distance divided by 5, vertical distance divided by 5, and then we go ahead and check here. We go over 1, up 1.4, over 1, up 1.4, over 1, up 1.4, over 1, up 1.4, over 1, up 1.4. If we look here, follow our lines up, each of these vertical lines is 1 space apart, and then each of our horizontal lines is 1.4 spaces apart. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So our line segment is now divided into 5 equal parts. So Q has got to be placed so that 3 of them are on one side, on the side closer to B, and 2 of them are on the side closer to A. So 1, 2, looks like Q should go right here. That way, 2 spaces for 2 segments for AQ, 3 segments for QB. And now the trick is just to figure out what those coordinates are. Well, to find our X coordinate, so X of Q There's two ways we could do this. We could start at B and count forward, or start at A and count backwards. We'll just start at A. So that's 3. Take away 2, and each step of 1, or each step on the x-axis was 1, so it's 2 times 1, which is just 2. So let's see, that's 3 minus 2, or 1. So x sub q equals 1. That's the x-coordinate for 1. And if you look here, that makes sense. You can see we're over 1. Now we want to find the y of q. So starting up here, our y-coordinate for A was 4. And we are going down, so it's take away. We went down 2 steps, 2 times. And each step was 1.4 on the y-scale. 1.4 on the y-scale. So let's see, that makes 4 minus 2 times 1.4 is 2.8. Let's see, 4 minus 2.8 is 1.2. So our y-coordinate is 1.2. And if we look here, over 1, up 1, and a little bit more, makes sense. So Q has coordinates 1, 1.2. Okay. So remember, first we had to decide how we were going to divide the line segment up. We decided, since our ratio was 2 to 3, then we were going to divide it into 5 parts so that 2 of them could go up here between Q and A, and 3 of them could go down here between Q and B. Then we measured the horizontal distance and the vertical distance between the 2 points, and we separately divided the horizontal distance into 5 smaller pieces, and we divided the vertical distance into 5 smaller pieces. We found that the horizontal distance, when divided into 5 smaller pieces, made 1 space, 1 unit for each piece, and the vertical distance, when divided into 5 separate pieces, became 1.4 spaces per piece. Then we marked out where over 1, up 1.4, over 1, up 1.4, and so on. Marked all those spaces on the line, and it looked pretty good. We had 5 equal sized segments. So we placed Q so that 2 of them were between A and Q, and 3 of them were between B and Q. Then to find the coordinates of Q exactly, we had to work from one end, and we chose the end A, but we could have chosen the end B. We would have got the same answer either way. We started with the end A, and we worked backwards by subtracting. First, we found the x-coordinate. We started with the x-coordinate of A, and we took away 2 steps back to Q, and each step was 1 unit. And we found that the x-coordinate for Q was 1. And then to find the y-coordinate for Q, we started with the y-coordinate for A, and we took away 2 steps, because we went down, down, and each step was 1.4 units in size. So 4 minus 2 times 1.4, we got a y-coordinate of 1.2. And we double-checked to make sure that made sense on our graph, and it did. And then, so the coordinates for Q were 1, 1.2. Now, since it took a little while, I'm going to do a separate problem on another video. And I think that you should probably try out, I'm going to do number 3, but I think you should try number 3 on your own. And then watch the video and see if what you do matches up with I do. And if it does, then you're in good shape to do the rest of the problems. And check your answers at the very end.